In this lesson, we are going to learn about acids and bases. We learned in our earlier lesson that there are various chemicals that exist in nature or are produced by a combination of two or more natural elements. One way of classifying these is to classify them as either acids or bases. In this lesson, we are going to look at what acids and bases are and how they come about. Let us first start with acids. An acid is a chemical compound that usually gives off hydrogen ions when the acid is combined with water. In other words, when the chemical reaction between an acid and water molecules occur, part of the products that are given off include hydrogen ions. For example, hydrochloric acid is a common acid you may have heard about. Hydrochloric acid is a chemical compound made up of hydrogen and chlorine atoms. When we add the hydrochloric acid to molecules of water, part of the products include hydrogen ions. The amount of hydrogen ions that are formed from the resultant chemical reaction determine the strength of the acid. If there are more hydrogen ions in the product of the resultant solution, it means the acid is stronger. Common examples of acids include hydrochloric acid, which is an acid formed by a chemical reaction between hydrogen and chlorine atoms. We also have sulfuric acid, which is a chemical reaction between hydrogen, sulfur, and oxygen atoms. Nitric acid is an acid that is formed by hydrogen, nitrogen, and oxygen atoms. Phosphoric acid is made up of hydrogen, phosphorus, and oxygen atoms. We also have carbonic acid, which is made up of hydrogen, carbon, and oxygen atoms. Let's carefully consider the hydrochloric acid in this lesson. As we said earlier, the hydrochloric acid is made up of hydrogen and chlorine atoms. Hydrochloric acid solution, which is a very important product, is used in the chemical industry for the production of various substances. Hydrochloric acids are commonly used in producing certain batteries. They are used in the removal of rust or scales that have generated on iron materials. They are also used in the manufacture of fertilizers. Hydrochloric acid is also a vital component used in the manufacture of PVC products such as pipes. There are many other uses of hydrochloric acid. Some acids can be found in nature. These occur naturally and are not created by man. They may exist in various forms such as amino acids that are found in protein, citric acids that are found in citrus fruits like lemon, grapes, and orange, lactic acids that are produced in milk products, acetic acid that is found in vinegar, and many more. We can also have artificial sources of acids. In other words, acids that are created by man. These include hydrochloric acid, which are produced directly from chemical reactions, sulfuric acid, nitric acid, carbonic acid, and many more. Let's look at some of the common properties of acids in general. Acids usually taste sour in the mouth. When acids come in contact with substances such as the skin or metals, they can corrode. This means they can wear away the substance. When acids come in contact with the human skin, they cause a burning sensation that can be very painful. It is therefore important to always protect oneself when dealing with acids. Acids turn blue litmus paper red. The litmus paper is a special kind of paper that is usually used in tests for acids and bases. Acids can be used as electrolytes to conduct electricity. Acids tend to react strongly with metals to produce salt and oxygen as products of a chemical reaction. Let's now shift our attention to the second part of this lesson, which considers bases. A base is simply a substance that accepts hydrogen ions. It does not give off the hydrogen ions but rather accepts them. It is a substance that can easily neutralize the effects of an acid. Examples of bases include sodium hydroxide, which is a combination of sodium, oxygen, and hydrogen atoms. We have potassium hydroxide, which is a combination of potassium, oxygen, and hydrogen atoms. We also have calcium hydroxide, which is a combination of calcium, oxygen and hydrogen atoms. Let's now concentrate on one very common base known as the sodium hydroxide. Sodium hydroxide, as we mentioned earlier, is formed from sodium, oxygen and hydrogen atoms. It also has various uses in our daily lives. Sodium hydroxide is used in the manufacture of soaps, detergents and other cleaning agents. It is also an important component used in the production of paper. Sodium hydroxide is used in the manufacture of hair straighteners or relaxers. It is also very important in the manufacture of textiles. Bases can be derived from natural sources. In other words, they can occur in nature. Examples of such sources include ash that is generated from the burning of wood. They are contained naturally in certain foods such as banana and margarine. A very common substance known as saltpeter used in cooking is an example of a base, and there are many more. We also have artificial sources of bases or bases that are created by man. Examples of these include detergents that are used for washing or cleaning, scouring powder that is used for cleaning sinks, wash basins and sanitary areas. The base ammonia is also an example of an artificial source. We have zinc hydroxide, and we also have baking soda and soap. Let's look at the common properties of bases. Bases taste bitter in the mouth. They also feel soapy or slimy when felt between the fingers. Bases contain metal oxides or hydroxides. A base, when tested on a red litmus paper, turns blue. Just like acids, a base that is in the liquid form can help to conduct electricity. Most bases can easily react with acids and salts in chemical reactions. Acids and bases can neutralize each other. What do we mean by this neutralization? Neutralization refers to a chemical reaction that involves acids and bases reacting to cancel each other's effect. If we are to neutralize an acid, we must add an equal amount of a base in terms of its molecular quantity. If the two neutralize each other, then we have neutral products that are formed. When we react an acid with a base, we usually obtain salt and water as part of the products that are formed from the chemical reaction. Let us look at an example of a neutralization reaction between acids and bases. This is a chemical reaction between hydrochloric acid and sodium hydroxide. The hydrochloric acid is an example of an acid, while the sodium hydroxide is a base. When the two react, we obtain sodium chloride and water. The sodium chloride is a salt, while we also have water being formed. Let's now look at the strength of acids and bases. We mentioned earlier that an acid's strength is measured by its ability to give off hydrogen ions. For bases, we can find its strength by looking at its ability to form hydroxide ions during a chemical reaction. There is a special scale known as the pH scale that is used to show the strength or weakness of acids and bases. Let's look at what this pH scale means. pH is an acronym that stands for potential of hydrogen. A pH scale is numbered from 0 to 14. Acids can be found on a range between 0 and a number that is just less than 7, while bases are between 7.1 and 14 on the scale. The number 7 refers to a neutral substance that is neither an acid nor a base. The strength of an acid decreases with rising numbers on the pH scale, but for a base, the strength increases as we have the pH numbers increasing. As we said earlier, for acids, while we have a rise numerically on the scale, the pH value decreases. In other words, for a higher pH number, we will have a weaker acid, but for a lower pH number, we will have a stronger acid. For bases, as the pH value increases, we have stronger bases. In other words, a lower pH value indicates a weaker base, but a higher pH value indicates a stronger base. This brings us to the end of our lesson on acids and bases. I hope you enjoyed it. Goodbye.